Hello, good morning, good afternoon. My name is Chiara Benetti, and on behalf of ETA Florence Renewable Energies, technical organizer of today's event, I welcome you to Task 33 webinar on gasification, a crucial technology for the energy transition, a global perspective. The webinar will be moderated by Bernd Freudenhill, TNO Energy Transition Innovation Manager, Gasification, Gas Cleaning and Upgrading from the Netherlands, and will be presented by Guanyi Chen, Chair Professor of Bioenergy and Environment at Tianjin University from China, by Sunil Dhingra, Senior Fellow and Associate Director, Renewable Energy Technology, TERI from India, and Itka Urbek, University of Natural Resources and Life Sciences, Vienna, Institute for Chemical and Energy Engineering from Austria. The webinar will be recorded, and the recording and presentations will be available from tomorrow on IA Bioenergy Task 33 website and on IA Bioenergy website. During the webinar, you can drop questions to our speakers by using the Q&A tab that you can find at the bottom of your screen. Our speakers will have the possibility to reply to you by typing the replies directly in the Q&A tab, or by replying during the Q&A session, so orally. Please do use the Q&A tab only for questions and do not use the chat box. So from my side, that's all. I leave the floor to Bernd Freudenhill, and enjoy the webinar. Thank you.
Yeah, good morning and good afternoon to everyone listening. I see there's almost 200 participants at the moment, so that's quite nice. We from IEA Bioenergy Task 33 decided to organize a webinar on gasification, and we try to get a little bit the global perspective. As some people might know, the task currently consists of countries mostly in Europe and in the US. And we invited speakers from India and from China to give their perspective on how gasification is developing in their countries. And I think we put together a nice program, and I would like to start by thanking the three presenters for putting in time and effort in making this presentation. I hope that all the listeners will enjoy this short session of roughly 2 hours. And as stated before, Q&A is open for all questions regarding the presentations. And as a final remark, I would like to point out that the session is indeed available after today on IEA Task 33 website. And next week, there will be also an interesting report published on the website on emerging gasification technologies. So just keep that in mind. Then I would like to give the floor to the first presenter from China, Professor Dr. Guanyi Chen. Well, Professor Chen, the floor is yours.
Okay, can you hear me?
Yeah.
Thank you, Chiara and President, to invite me to introduce, to present what we have done, and also what I have known in China, the waste gasification technology development. So can you hear?
We can hear you. We do not see the presentation yet.
Can you see the PPT?
Not yet. Now it's, yeah.
It's okay?
And then in view mode, yes. Thank you.
Okay, ladies and gentlemen, once again, thank you very much. I'm happy to see you in the webinar. So my talk is a waste gasification and application progress and challenge. Because in particular in China, I'm Guanyi Chen from the Tianjin University and also Tianjin University of the Commons and also Tibet University. So my presentation includes very briefly potential of waste in China for gasification and then technology development. So focus is a case study of the industrial application, and then discussion of challenge or maybe outlooks, and then finally a brief introduction of my research team. So potential of waste in China, there are huge amount of waste can be used for gasification, including, for example, municipal solid waste, very huge amount of waste in China for gasification, municipal solid waste, agricultural and forest waste, and also industrial organic waste, for example, textile waste, herbs residue, and vinasse. So the chicken, cow dung, chicken manure, and corn cob, and a lot of municipal solid waste be gasified in China. There are also some example later I will introduce. So in total, there are 5 billion tons waste could be used. Next. So usually the principle for waste disposal, okay, now we start usually the reduced amounts, and then make it harmless, and then recover the source. Finally, is produce value-added product. So gasification is possible to take value-added product from waste. So this also increasing China the awareness. So if we will look at this, if you say the y-axis, the temperature range, so you can say between 500 to 1,000 degrees, this proper range of the gasification. Some separate with pyrolysis, and incineration or combustion, but sometimes integrate together. So it's a large range of temperature. So in this case, the product could be produced for gasification. For example, energy, including gas, heat, electricity, hydrogen, diesel, and ethanol. But also chemicals in China, tar-based product, we produce pesticides or foliar fertilizer. This is also in China. And also the power generation produce gas and biochar carbons for environmental application or energy storage. So there are quite a different application. So if we look at the technology, okay, usually gasification is quite complicated. Actually, you integrate different process, for example, drying process, pyrolysis, particularly for pyrolysis, is gas liquids, and it involves some gas phase reaction and also charge gasification reaction, and finally charge combustion. If you say the process is complicated, but usually we control the key steps. For example, pyrolysis to gasification, and from gasification to combustion, how we can control. That's the key steps. So now here are a few what we are developing in China now. Just flip briefly, okay. Emerging, we can say emerging gasification technology. There are a number of cases working now. For some wastes, you starting with anaerobic digestion or fermentation, okay, as a pretreatment, or after that, then the residue or medium product go to be gasified. So in this case, could be the gas can be produced as much as possible. So this is a way to produce a gas product with maximum efficiency, but also with affordable cost. But also in some cases, the hydrothermal liquefaction is a first step for waste, and then continued by gasification. This is another case. So it's developed in China now. And also the key point for gasification is how to develop efficient or good gasifier. Actually, we have a lot of experience, or maybe for a long time, but still gasifier still not very reasonable. We think so. We develop the reverse desire of gasifier. It means, for example, originally gasifier is designed based on the feedstock, right? But now, but in some cases, the end user, for example, for heat, in summer and in winter, the heat load is completely different. So in this case, end use need flexible demand. So how we gasify can be suitable. So that's the idea. We start from gasifier design based on the end user demand, and then go back to feedstock. How we get the balance of the feedstock and the gasifier. This is also the technology we are developing now. So I skip this because later we will focus on the case study, okay? But also the fermentation gasification technology is working now, and also the syngas. If we take the syngas or synfuel as the main product of the gasification, and also we can take hydrogen as the major gasification product, okay? We can take carbon together with gas as the main product. Okay? We can take heat and electricity as the main product. So different product. We have to think about maybe different process of the gasification. That's the idea we should consider. Okay. Okay. The focus is a case study of this presentation. The first case is using agriculture and forest residue for gasification. The first case study is Yixing, Heilongjiang, is polyutilization work for the 500 household. And okay, this is actually is normal gasifier. Okay, for example, the high level is 10 milligram per normal cubic meter. Is a low heating value gas produced usually still for the household. Okay, we invest the household few times is okay. Is still acceptable this gasifier. The second is the Anhui province. Is also polyutilization based on rice husk as feedstock. They produce electricity mainly. So and other, they also biochar as a byproduct, and also some vinegar, put vinegar. So now this project are working very well. They have, it looks to have very good economic profit. And the third is Jiangsu Nantong, is a high temperature gasification. Is using rice straw as feedstock. Every day they use 7 tons of feedstock. So you can see here the gasification temperature is very high, almost 1200 degrees. And the fourth case is Hubei. It's based on the fluidized gasifier to produce electricity 6 megawatt. Use a different feedstock, for example, blanch, wood chips, and also corn copper and corn stove. So it looks very flexible to use a different waste as feedstock. The fifth case is located Hunan province, but also mainly feedstock is the rice husk, the capacity 2.5 megawatt. Production of the fertilizer and also fuel gas. What does it mean, fertilizer? Actually, fertilizer is based on the charcoal or biochar, and then with added some nutrition together, and so they got to put the fertilizer, but also got a part of fuel gas. That is also good project. They are working very well. So this use municipal solid waste as a feedstock for gasification in Fujian province. 300 tons per day to treat the waste in the 15 megawatt electricity. Best. So the process is okay. Municipal solid waste coming to the warehouse, and then scratch with pretreatment scratch to get RDF, and then RDF go to fixed bed gasifier, and the sludge go into the building material. They make building material sludge, and then the fuel gas go to combustion chamber to produce heat and electricity. So this project also has been running 2 years. The profit looks okay. This is the industrial waste case study, located in Shandong. The fixed bed gasifier 250 tons per day of the medical herbal waste feedstock. So the project also has been running 3 years already. The main product is electricity, because the herbals, medical herbals company factory, they need electricity, so they use the waste to produce electricity, but also produce steam they need for the process industrial. So for the detail of the technology, I skip, okay? So this is another case study, use the textile waste as a feedstock for poly generation based on gasification is 30 kilowatt. So the output also there by char and also with the vinegar, and also electricity, okay? Another case is in Shandong province, Guyana, is used the biogas residue as a gasification feedstock. Actually, you know, the factory, the company to dispose medical waste based on the fermentation or anaerobic digestion, but part of the residue from the fermentation, after fermentation, and then go to the gasification. So in this case, there are no, in this case, the waste can be fully treated without the environmental pollution. So this project also been running 4 years, but it's, okay, it's a small or middle scale. It's not a large scale, but it's proof it's same is okay for technology. So here is the case for the gasification of much feedstock, including agricultural biomass and also waste agricultural film, and also part of the bituminous. In China, also the waste agricultural film is also serious problem for the environmental pollution. So in some villages or in some urban towns, so how to deal with this waste is you got a very increased concern now. So this is the 500 kilowatt per hour capacity, and efficiency 35%. Actually, also the capacity is not big, but still prove the technology or process is working very well, and there are some financial subsidy from government to deal with the waste agricultural film, so it's still working nice. Here is another example, high temperature, another high temperature method gasification. You can see here the municipal solid waste input and then compression of the waste, and then go to high temperature gasification. Because of very high temperature nearby 1,500 degrees or 1,400 degrees, so the sludge is a liquid sludge. Okay, go down, and then the sludge going to make different very beautiful product. Okay, looks, and the gas after purification, you get the electricity and steam they need. Okay, so this you can see the sludge. That's liquid, and then the different product. Now they are building a large scale of the multi-gasification project. So this is the project is under construction now. So another case is the conic fluidized by the gasifier. Use the rice stroke located in Philippines, also technology and the facility developed in China has been run in a few years, only 5-6 years. It looks very well. And this is the gasifier integrate with the rotating furnace. It means first the first waste go into gasifier, and then the gas go to rotating furnace. They together input together, they make a very close, very compact structure. Also the kind of part of carbon as a product. The carbon is also good to make a profit for this process. So the right side is another gasifier, the train gasifier, using the garden waste and the rice husk together as a feedstock. So 6 megawatt capacity, also part of the co-production of the carbon. So you can see several, now more and more the gasification project in China, so mainly to produce, partly produce gas or electricity, but also together to produce carbon. In this case, they can make a more profit. So this is developing. So okay, I'll skip this. And then a few minutes, okay, what challenge now? Okay, challenge is, okay, more and more waste feedstock to come to gasify. So how gasifier can be flexible to different waste? Just in China, actually is a problem now. And also the application, if we produce syngas as a product, or produce electricity or heat, or produce carbon and syngas together. So depending on the final product, so we have to consider different gasification process. So we have to be careful, something like that. And also pollutant, particularly for some waste, for example, textile waste, waste agricultural film, and also some municipal soil waste. In this case, application should be very careful because they have to sometimes produce sensitive pollutant. So we have to think about how gasification can work very well, and also with good performance, but also with very, very less pollutant release, and better than combustion or other technology. So also in this case, and also the tar control is depending on the end product. If for producing gas, tar control is also very important. If produce electricity or heat, maybe tar control is not very important. So anyhow, we have considered different case, different application, and also we are developing tar in tar remove or tar online measurement for industrial case, not for lab. Okay, we have different lot. I skip this time. Okay, and also the thinking architecture I mentioned earlier to how we can consider develop gasification to integrate with the pyrolysis, maybe, or integrate with the combustion, and also integrate with the fermentation, and also integrate with the other, or maybe hydrothermal process. So this is the very interesting topic. We consider gasification maybe a medium technology. It's best to be integrated together with the other process. In this case, the efficiency or economy, the profit maybe could be better. So also last maybe, okay. Yeah, here I mentioned, okay, from energy efficiency, from the environmental pollutant point of view, how we can control the boundary of the gasification and pyrolysis, the boundary of the gasification and combustion. This is we have to consider when we design and operating and when we operate gasifier, we not, and also the coupling, how the gasification can be coupled or integrated. That's we have to be careful, okay, and also pay more attention to that. My team last minute is a looks big team who work for gasification and technology, and also we have international conference. I must waste for energy and environment every 2 years. So we hope, okay. And also this year we hope this conference in Qingdao, but hope to see you again. So I stop here, okay, during time limit, okay? It's okay?
Yeah, it's okay. It's thank you, Dr. Chen, for presenting on what's going on in China. It's impressive. I've seen a lot of different technologies passing, and there's many questions in the Q&A below. And perhaps you can during the webinar answer some of those. But what I think what's nice to hear from you is how is the Chinese government supporting gasification technology towards it being applied, because you see it's used for heat and power. And Pelkmans asked, is there incentives, for instance, in China? But also, if you would like to go to biofuels or chemicals, are there any policy measures in China that support this development?
Yes, okay. I also answer your question and also answer the questions in the website, no, in the internet, right? So yeah. I just take some questions, okay, one by maybe a few. And for your questions in China, the government actually, now in last 2 years, the government policy to support gasification of waste is getting increasing now. Usually before we develop gasification usually for the agricultural waste before. For example, 5 years ago, 10 years ago, the gasification mainly for agricultural waste. But now, because the government put more policy, more financial incentive to municipal solid waste, to industrial waste. So in this case, we change our focus from the agricultural waste to the industrial waste or municipal solid waste. So we get more, in this case, we can get more financial support from government. So the gasification in this technology development faster than agricultural waste now. Okay, but very interesting point. The last year our president mentioned the 2030 year carbon peak, carbon reach to peak in China. So now there are a lot of discussion how to pay more attention to biomass, particularly for gasification, because gasification is a very flexible technology, can be easily connected with other process. So in this case, gasification, I'm sure gasification will develop far, will again, okay, develop, get more attention. It's for your question, but also for the question in the website, okay, for internet, okay.
Yeah.
There's some people were how many gasifiers in China, but also how many different waste in China. Actually, how many gasifiers? Huh?
Maybe it's to answer a lot of these questions just by typing the answer. I think people can read it then also. And maybe one final question before we go to Sunil for the next presentation, because I was also wondering, and that's one of the last questions in the list, is also about carbon capture and storage. And I think this is quite relevant when talking about gasification of biomass and waste, that you end up with CO2, often in a nice pure form. Is there also developments ongoing to either utilize the CO2 or to store it in China?
Yeah. Yes, you mean for CO2 sequestration, okay,
yeah.
Capture, right? This is the. I agree with you. To to get more chance for also for gasification I'm sure for this, because we also have in recently we have a lot also several times discussion on how to develop gasification process to be with the carbon capture and sequestration. But also this we have sometimes it's a controversial, because we have to combine together pyrolysis and gasification. Is not easy to separate it together. So sometimes, in my opinion, okay, pyrolysis can be part of gasification, something like together, okay, and we can integrate together, and then we say gasification, okay. If we separate pyrolysis with gasification, sometimes it makes it harder actually. So how we can for our because this is the gasification task, okay. So I would suggest that we can move a little bit, okay, or forward or behind, something like that, gasification, okay, to be flexible for carbon sequestration and carbon capture, right?
Yeah. Okay. Well, as you can see in the Q&A, there's a lot of questions.
Yeah, there are some financial instances in China for producing electricity from biomass or waste, okay? Actually now, the government try to remove financial support for the biomass to electricity, try to remove. So, but in this case, we think, okay, biomass to syngas, biomass to gas, or biomass to gas together with carbon it's possible to get financial support, okay? So electricity is hard now. The government is trying to remove policy support, but for syngas, for fuel gas, for generation, maybe it's a chance now, okay?
Yeah.
And also the last question, okay, say the tar is a zero problem in gasifier. How did you collect and utilize tar from the gasifier? Actually, this is a very good question. Okay, tar, as I mentioned earlier, for depending on the end user of the gasifier. If we want to use gasifier to produce electricity or heat, okay, tar is not a big problem, because we can connect gasifier with combustion very closely. So tar is not a big problem. If you want to produce gas or syngas or other product, and then you have remove gas very carefully. How we can do it very simply, okay? So the most important is, okay, you have to design good gasifier and operate it very well gasifier, but also very good, very fast, quickly, good cooling of the tar. Anyhow, there are some tar, okay? But also, okay, part of catalytic remove tar. But anyhow, so and also chemical remove tar. Just how to combination, how we can make combination. That depends on economic profit, depend on economic cost. Okay, so there are different solutions based on the economic cost. So it's not a single solution how to solve tar, how to anyhow depending on any user. Okay, depending on any product we have to. So, okay.
Okay. Well, thank you for your answers. We will now go to our next speaker from India, Mr. Sunil Dhingra. Well, the floor is yours. I can see your presentation.
Okay.
Still see
So good morning and good afternoon, depending upon which time zone we are participants are located. And at the outset, I would like to thank IEA Task Force and the TNO who Energy Transition Innovation, who organized this webinar on very important subject, biomass gasification programs global perspective. So what I intend to do in my time allocated for presentation. I will touch upon the biomass gasification in India from the technology, potential, and key challenge and the future needs perspective. Just a minute. Okay, now, so the outline for my presentation would be in this flow that I will present that brief history of biomass gasification, different types of biomass gasification design, which has evolved both from the research pilot scale and also the commercial scale. What are the key potential market segments for gasifier in the country? Looking at some experience and achievements already done and some of the key learnings which are important for scaling up this technology. Then of course future R&D needs and some of the glimpses of biomass gasifier project. So coming to the overview of biomass resource in India. As you can see from this slide that biomass feedstock supply, we have large agriculture waste, which is coming from agriculture residue at the farm level. And also while processing some of these produce at the industrial scale, then you also produce agro-industrial waste. Like for example, bagasse, for example, which comes from sugar mills while processing sugar cane and also rice husk. So we categorize two different categories of agriculture waste, one which comes from farm waste, the agriculture waste, and the other one is the agro-industrial waste. There was some quantification of 11 major crops which happened in 2018 by Government of India. So something around 683 million tons of major crop types was grown annually in the country as per this estimate. And out of that, 178 million tons is considered to be a surplus quantity, which is not being utilized. So there's a big scope for technology like gasification or any other biomass to energy application to play in this energy or non-energy application. And as I told you that there is a large quantity of agriculture, agro-industrial waste in form of rice husk, bagasse, and some other oil crop husk which are available and generated in the mills. At the same time, India also generates something around 188 thousand tons of MSW on a daily basis, which comes to about close to about 70 million tons of, and part of that can be gasified for energy application. So this is also we consider a major resource for gasification going forward. In terms of gasification, India has a very large, historically emerged as a technology leader in a small scale fixed bed gasification, both for heat and power application. We have exported Indian make gasifier design to over 40 countries in all continents, I would say. So there is wide range of outputs from a few kilowatt to a few megawatt, which has been evolved from this program. The driver for biomass gasification is essentially to reduce dependency on energy import bills in the country and to achieve goal for low carbon energy transition pathways, which is driving this gasification program. Coming to the history of biomass gasifier, as you can see, the biomass gasification research commenced in almost about in 1980s, and there are leading R&D academic institutions like Indian Institute of Science, a few IITs, TERI, and many other institutions got involved in various aspects of gasifier design and development of gasifier technology components. And the initial year, the emphasis was basically to replace diesel, and largely in the agriculture sector, in the pumping sector. And subsequently, small-scale systems of biomass gasifier are also developed for rural electrification needs to provide energy access to communities which are not being accessed through the national grid. So there, the emphasis of gasifier was very high. Further, the gasifier technology, as some of these objectives were met, the technology or the market for gasifier was expanded to sub-megawatt scale, mainly for grid application. And also very important is, as you will see in the future slides also, the industrial thermal energy applications, which is the heating demand of industries in form of heat in their processes. So that becomes very important from gasification development and deployment point of view. A gasifier system based on various fuels like specific to rice husk and some of the stalks like cotton and wood chips have been developed, indigenized. And there are more than 15 leading manufacturers in India who are manufacturing this system both for domestic and the export market. If I see for electricity output range, the gasifier are something around 10 kilowatt to something around a 2 megawatt scale, and thermal gasifier from 25 kilowatt thermal to something around 5 megawatt thermal is successfully deployed in the country. If one look at the different designs of gasifier, I would say the fixed bed gasifier with downdraft gasifier, open top gasifier design, which is specifically developed by ISC, then updraft gasifier, and then stage gasifier based on two-stage gasifier principle have been very common and a commercial scale available in the country. One look at from the fluidized bed gasification, the work is still in, I would say, the lab or the pilot demonstration stage, particularly on the circulated fluidized bed gasifier, low temperature fluidized bed gasifier utilizing some of the straw, like for example, paddy straw, which has low melting temperatures and not very effective for fixed bed application. And some work on plasma gasification is being carried out in lab and pilot demonstrations scale. But so far, if you look at highly robust, efficient, and flexible thermal and power generation from biomass gasifier system have been evolved through this development. One look at from the market perspective, as I indicate you, there are two very distinguished markets are there. One is this for power application, both for rural mini grids application, where the scale of biomass gasifier is very common, is 10 to 40 kilowatt, both for energy access application and also for productive needs requirement in the rural areas, running a small factories or processing of the needs in those locations. So where gasifier based systems are very important. Then the other important market for electricity or power market is for captive and grid application, like for example islands which are depending upon diesel as a source of electricity, and many industries which are in the remote location where reliability of grid is limited. So people, the industry depends upon these kind of a system which can provide power in the range of 50 kilowatt to about 2 megawatt. It is well established, the economical attractive when diesel has been replaced as a base fuel. So their gasifier is very much economical viable. On grid, the cost of electricity because of fuel cost and high operation cost the price of electricity is in the range of 6 to 8 rupees per kilowatt, which is not that attractive when we compare with solar PV, for example, where large scale solar PV based electrification is happening in the grid system. So many utilities are not very attractive with biomass based or gasification based plants at the moment. But in thermal gasifier, as I told you, the biomass gasifier with the very package has been developed in this capacity range, and very clearly in MSME sectors like micro, small, and medium enterprises, this has biomass gasifier has become a very important cost-effective energy delivery system, where this is commercially scaled up. This slide will give you a perspective of thermal energy needs of an industry. In this case, we have considered about 50,000 kcal a typical output, and if the choice is between these type of fuels, as you can see in the electricity, natural gas, LPG, so industry has these many choices. And very clearly, if you look at from the on this table, the producer gas, the syngas, which is produced on that particular efficiency, the price is only 125 rupees for that amount of heat if I have to produce. Whereas all other forms of fuels, they are very expensive for micro small. And that is what it is driving the sector. And as you can see that some of the potential MSME sectors where temperature range something around as low as 60 degree to something around 1000 degrees Celsius has been achieved through this small scale gasifier system. Like for example, silk reeling, rubber drying, textile processing, hot water steam generators, food processing industry. So there are millions of such small scale units are there in the country, which are being converted into a biomass gasifier based system with supply chain arrangement being made on biomass fuels, and also for creating local manufacturing and service delivery model in those clusters. These are some of the clusters in map of India where you can see different clusters are there, as I indicated you before. So these smaller clusters are where gasifier are being used and replicated from energy delivery point of view. It has generated a positive spin-off effects within the cluster and also across different other clusters. It has also creating local manufacturing of gasifiers and service delivery models by local service people. So it has given up the co-benefit not only from the energy perspective but also from job creation perspective also. So this is the positive impact. The green jobs has been created around this cluster, not only in the manufacturing but also in providing services support to this small cluster. Very important is that there's a high cooling energy demand in the country, and as per the India cooling energy program or projection, we could see that there is a 8 times growth of cooling energy in the country in next about 10 years or 15 years time frame. And there are designs of gasifier which are specifically coupled with absorption chilling system, and you can see a small 15 to 30 ton cold storage system which is required in the agriculture farmhouses to store either milk or horticulture crops, fishery for example, for intermediate storage application. These standalone biomass gasifier based cold storage systems have been developed very successfully, And these type of systems are helping farmers to store their perishable products in their farmhouse, wherever these are produced. As you can see, the gasifier, which is running this absorption chillers, and it is and on the back side there is a cold storage system which is running through a biomass gasifier system. On the power generation side, as I told you that biomass gasifier produce some impurities in form of tar and particulates, which need to be cleaned and the gas is to be cooled before fed into gas engine, which is commonly available for power generation applications. So this is the scheme of cooling and cleaning system, which has been adopted by many suppliers, manufacturers of gasifier design. Typically, if you look at from power generation point of view, these are downdraft gasifier design, again fixed bed. Some of the design has adopted wet ESP system to produce ultra pure gas, something around less than 10 mg per normal meter cube. And other feature could be the dry ash handling system, so that this can be used for either for as a biochar or for any other purpose in the agriculture field itself. Fully automatic PLC and SCADA operation systems have been developed, which meet the gas quality requirement of most of the leading engine manufacturers in the country. This is a picture of a 1 megawatt gasifier plant grid connected system, which is very close to New Delhi, where different forms of biomass and some of the waste material is being utilized in this plant, and through this battery of engines, the power is being exported to the grid in that system. If one look at from, this is a multi-feed gasifier system successfully operated on loose biomass, wood chips, and also the RDF, the extracted from the MSW, which is available in the local community. And typically the specific fuel consumption of these plant is close to about 1.2 or 1.1 kg per kilowatt hour. The tar content on a is less than 15 milligrams, and the water consumption in the cleaning system is close to about 0.6 liter per kilowatt hour, the fresh water requirement. And these kind of systems have been very successfully operated under some field conditions annually about 7,000 hours, and these are synchronized with the local grid for grid application. We have this is a case study from a rice husk gasifier which has been exported to Guyana, and very effectively this has replaced the electricity and also the diesel, which was the base case in this rice mill. And as you can see, this unit, the rice mill unit, was spending about Guyana $33.2 million annual cost to the electricity. But after installation of these gasifier, they could able to save about on annual basis about 28.9 million Guyana dollars, and the payback of such system is almost less than one year. So as you can see that wherever the diesel has been the case in the current price, the payback of such system is very attractive for rice mills or any other forms of mills. Here I would also like to mention that we at TERI have also partnership with Danish Technical University for quite some time, and we have evolved very advanced by combining TERI fixed bed gasifier with Viking gasifier. This two-stage gasifier design, which is very effective both for energy conversion point of view and from the efficiency of resource efficiency point of view. So these are some of the future project we are scaling up these kind of a system both for Indian market and also for future development of system. We are this is an important area where we are hybridizing the biomass with solar energy, which is and trying to develop solar biomass electricity and cooling solution specifically for rural India under this mission innovation program, which is supported by Government of India under Department of Science and Technology. And under this program, IIT Delhi, TERI, and DTU, that the Delhi College of Engineering, are Indian partner, and we have partner from Europe side, which is the CA Tech from France, INEA from Italy, and Energy Farm International, which is a Norwegian program. So trying to develop these kind of solutions. Some of these solutions have been piloted already in our campus in Gwalpadi, and now we are trying to pilot it in actual field condition at the moment. From the future perspective, the work on the R&D is trying to aim at reducing cost, both I would say in terms of initial investment and also the operating costs by improving the efficiency and increasing the resource efficiency point of view, so that one can compete with the current grid cost through this biomass gasifier based system. And of course, the important aspect is also increasing the reliability of power gasifiers at the ground, which is very, very important. So these are some of the areas where more advancement is currently happening. The focus is also on dry cleaning system with no requirement of water, for example. So that is the focus of future development in biomass gasifier based system. And then developing new options like solar and biomass hybrid, solar PV based or solar concentrated based biomass combining with biomass, so we can have 24/7 renewable energy plants which can operate both on solar and non-solar hours through these kind of a system. We are very strongly looking cooling energy demand from biomass gasifier based system, as I shown in the previous slides. Trizations application like heat, power, the residue as a soil enhancer are some of the important area where gasification research is happening. Going forward, biomass gasifier for production of hydrogen is important area where some of the research work is happening. We are very important from utilizing RDF, from the MSW for power generation, where some work is happening on ground, both from the gasification development perspective and also from utilizing non-standard, low caloric value, high moisture content fuel type. So those kind of a standardization is also trying to work on. Then of course the zero liquid discharge, as I told you, that dry cleaning system we are trying to look in. Then in some form the gas to liquid technologies, particularly from syngas to ethanol production, looking at from gas fermentation route is very promising in Indian situation where some work is happening. The catalyst gasifier, both for coal and biomass for green hydrogen production, syngas to methanol and ethanol production is happening in some of the labs in the country. at the moment. If you see, while work has been happened on the first box, the power generation, thermal gasifier, which I talked about in hot water, air generation, then cooling requirement, boilers, and all this. The next box is basically the gas to liquid or hydrogen production, where advanced biofuel applications in form of hydrogen, syngas to ethanol, methanol, and syngas to aviation fuels are some of the promising area where gasification, thermal gasification based systems are very important for the country, both from the utilizing biomass resources we talked about and also from the application point of view. These are some of the gasification project glimpses. I will just run through with that. These are very small scale gasifier system used in MSME sectors, various types in volumes in the country. We have seen that the small scale gasifier here, the two-stage gasifier has been used for bamboo processing. And you can see there are large bamboo processing units where cutting and some mechanical loads, where a lot of employment, the rural folks, and through utilizing this bamboo waste in these campus using gasifier are very real example of sustainable biomass growth and its utilization for energy and also for productive need requirements in rural areas. So these are very important example which this technology can meet. We have seen that the village electrification program, we have supported many countries like for example, there is a picture here where biomass gasifier is being used for supplying running a health services in Delta region of Myanmar, where this in 2009 there was a super cyclone, and very quickly we could able to establish gasifier based energy delivery system to run this emergency services. So this technology can very important in those locations. We have supplied some of this export gasifier. This is 1 megawatt gasifier plant which is very successfully running in Slovakia, and I think there are series of this 1 megawatt system have been implemented in Eastern Europe because of attractive market in those areas. Some of the system in Thailand running on coconut shell, which are very successful example of gasifier technologies in those countries. And I think here I can stop and maybe I'll hand over to the moderator of the session to continue with the QA session.
Yes, thank you, Mr. Dhingra, for this nice overview. I think again the Q&A is nicely filling up with questions for both speakers so far. So if you could in the next session maybe answer some of the questions as well. I had two, and I think they cover a little bit the questions in the Q&A as well. The first one is that the wastewater produced contains a lot of tars, and it's one of the developments for the future to go to zero water discharge. But what is currently done with this wastewater?
Okay, right now most of this wastewater which is generated is being collected in a pond, and the segment, the tar or the tar-laden waste is being collected a solid form and used to make briquettes, and then used in a secondary energy delivery systems like cook stove or maybe some furnaces, all those kind of a thing where this low-grade system can be, and water is being evaporated through these ponds. So this is the very common practice you will see currently happening in these plants.
Yeah, and my second question is related to which, when I listen to the beginning of your presentation, you see a lot of applications, small-scale applications for thermal heat, also for cooling, and remote electricity production. And I was thinking the reason that gasification is so well, I think spread out over India is perhaps due to the fact that the power grid, the electricity grid, is not that reliable and not that widespread over India. But are there also programs basically developing this power grid which will in the end push away the gasification applications, or what's your opinion on this?
There are two very important industrial heat demand is largely met through either coal, wherever the coal linkage is there in their furnaces, and also from a fossil fuel perspective, furnace oil, diesel, LPG. It has not been the case. Electricity is being used for heating application. Electricity is even expensive converting into these form of heat energy in that scale. So most of the MSME sector depends upon these conventional fuels. And as you see in the comparative table of fuel types, the biomass gasification based energy delivery system is the most economical options. The critical conditions there is that availability of biomass or the waste in that cluster. So as long as the alternate feedstock is available, the biomass gasification becomes a very important choice in those industrial clusters. And electricity being available, it's more expensive from industrial heat application point of view. But in the rural electrification perspective, there are two prominent programs which has happened. One, the national grid has reached all the villages. That's number one. So people dependence on grid is very, very high. The issue is more on reliability of the grid in those remote locations. So people either depend upon off-grid solutions like solar, which is cheaper solution as of now because of the cost consideration. But gasifier has a niche market, I would say, where productive loads are there, the motive loads are there, where I have to run a factory, for example, or a processing of agriculture needs to be done, where solar PV is even more expensive. In non-solar hours, the meeting that demand, the critical demand, it is not only the lighting load, it is more motive, running motors, pumps, and all those kind of a thing. So we could see the gasifier has a niche in those markets. And we are trying to, as I can show you that, trying to hybridize solar PV plus biomass gasifier as a combined solution so that we can harness fullest the renewable and at the cheapest delivery model, and combining other forms of energy like energy vectors like cooling, other forms. So that will make more economical from a rural electrification point of view. So that is the aim, this technology we are trying to develop.
Okay, thank you for your answers. I think for now we will go to the third speaker, to Jitka Rebek. She's co-leader of Task 33, and she will give an overview of.
Hello everybody, my name is Jitka Rebek and I am a senior scientist at the University of Natural Resources and Life Sciences in Vienna. Today I would like to speak about the status of gasification in 9 countries. So I think there is something to do, so let's go ahead. At the beginning, I would like to say some words to our task 33 and then speak about the status in Austria, Germany, Italy, Netherlands, Sweden, United Kingdom, USA, France, and Spain. Our task 33 is a working group of international people with focus on thermal gasification of biomass and waste. At the moment, we have 7 member countries, 6 European and 1 from the USA. All necessary information could be found regarding the task at our website. I would like to say that the website includes also a database on the right side. At the moment, there are about 20 reference facilities active in the database. Not all of them are in operation status. And I would like to also say that we meet as a group twice per year, where all country reports are updated and presented. And this is not secret, so it is always published at our website, so you can check the status at each country in task meetings and presentations at the section here. So I will start with Austria. At the moment, we have in Austria 6 producers of gasification facilities. All of them are in small scale, as you can see in the table. The output is between 18 and 550 kilowatt electric power and 44 to 880 thermal kilowatt output. At the moment, there are about 140 combined heat power facilities, gasification in Austria, and all are in small scale. Besides Austrian facilities, we have also the producers from Italy and Germany. I would like to talk about one company called Synfuels. They are not focusing only on power and heat production. They are focusing also on charcoal, and they produce it in very high quality. Their system consists of state gasification, and the gasification reactor is the floating fixed bed gasifier. At the beginning is the feedstock pyrolyzed and then gasified. And then after the cleaning, the gas is used for power production and heat, and the charcoal is used for in different ways. For example, terra preta for soil, then for animal feed and water treatment. And the last is also green road. It is possible to add this charcoal into the asphalt, into the streets. So, and in this way, to save CO2, so we can say that 1 kilogram of charcoal is an equivalent to 3 kilograms of CO2. And it is also a mission of Synfuels company to be negative in CO2 footprint. The next is a project Waste to Value in Austria. It is a 1 megawatt dual fluidized bed gasification and synthesis of Fischer-Tropsch. So the status now, so maybe you have already heard about it. Now it's the facility under construction, and they plan also to build a small research facility to use the slipstream of the gasification for different research projects. And in June this year should go this facility into operation. The next slide is about Germany. You can see here on this map all stakeholders in Germany. In yellow, research and development. In green, industry in small scale, and in red, industry in large scale. So as you can see, there are several projects undergo and several institutions involving in research on gasification. One of them is Pyrolytic pilot plant, which was developed at Karlsruhe Institute of Technology. The aim is a production of synthetic biofuels and chemicals from biogenic residues. They used already different feedstock and tested it. Mostly is straw used in this process. Process is 2 steps. At the beginning, the straw or feedstock is pyrolyzed, and then it is gasified in entrained flow gasifier. So as you can see, it is a technology readiness level 6, and mostly twice per year, they have a campaigns where the facility is in 24/7 operation. And actual information, I would recommend you to visit the Germany country report for the updated information. The next one in Germany is RWE sewage sludge. They treat a sewage sludge to win phosphorus. You can find this facility also at our database and at the Task 33 website. It is an entrained flow gasifier. It's atmospheric recovery land, and the temperature is about 1,500. And it goes into operation in April 2021. The next country is Italy. At the moment, there are only small-scale gasification facilities in operation. We have a data from 2019, but the updated data will be presented in our next country report and published at the website. So as you can see, there were about 267 gasification facilities, and now something about the near future of the gasification in Italy. There is an initiative by NextChem and Eni called Circular District. In this project, as you can see, there is by 2023 plan to start up a plant for waste to methanol, and also a plant waste to hydrogen. So there is I received a lot of information on this project from our Italian representatives, so please go to our website to get more information about that. The second project, which is very interesting, is waste to grids. Here is the waste material used for gasification. Afterwards is syngas produced and methane, and they used also solid oxide electrolysis cell or a solid oxide fuel cell to balance the grid. So this is a Horizon project with 5 partners, and they are focusing on southern part of Italy. So you can see much more data here. They take into account the availability of biomass, availability of photovoltaic power, and availability of wind power, and calculated together with biomass gasification to cover or to balance the electrical grid in Italy. The next is the Netherlands. On this card, you can see the stakeholders in Netherlands. These are also companies and research institutions. And there are several projects undergo, but I would like to pick just some few of them because of time problem. So I would like to say something about Sinova. Sinova is a technology using waste fuel, using Milena gasification system and Olga tar remover. They produce syngas, which can be used in many ways for electric power, for methane production, and also for liquid chemicals as hydrogen. The next is Torgas in Netherlands. Maybe you have already heard about that. It's a technology using a torrefaction at the beginning, then low temperature gasification and high temperature gasification. So this ensures a very high quality of syngas, which can be used also in many ways. And the third I picked from Netherlands is projects where the waste streams are used for hydrogen production. It's a project called FUREC. It's from RWE. And the capacity will be about 40 kilotons per year for hydrogen. The whole technology chain will be built. So it means waste separation and drying, torrefaction, Siemens gasification technology, and flow gasifier, and hydrogen production and CO2 production. A process was already tested in Freiberg. So to go ahead to Sweden, here you can see the Cortus wood roll gasifier, which is implemented in Höganäs steel plant. Biomass is dried in a rotary kiln, then it is pyrolyzed, and afterward it is gasified to syngas. Cortus is active not only in Sweden, but also in the US. They get a grant for producing 2.7 megawatt electricity. They have a collaboration, Cortus, Woodroll, and NG. They have a collaboration called Wood High, which was initiated 2019 on biomass to hydrogen in France. And I would like to say that Cortus has also patented a pressure swing adsorption purification that enables 15% more hydrogen output than other conversion systems. The next company in Sweden, which is well known, is MEVA. MEVA is entrained flow cyclone gasifier, which was developed at Luleå University of Technology. Its output is about 1.2 megawatt electric power. Feedstock is a very, very fine small fraction fuels as sawdust, wood fibers, or agriculture residues. And applications combine and heat production, and also drying processes in industrial technologies. They have a joint project with Andritz. They have to make a complete gas burner test facility to enable engineering of industrial burner installation for processes. So if you need more information, here is a link on the bottom of the slide. And projects under development in Sweden is Bioshare. The company has granted now funding for a period to 2024 to demonstrate integrated gasification and pyrolysis and at combined heat and power plant. The reactor should operate during 3 heating periods to assess the performance. And they want also test different downstream units in pilot scale. And last slide from Sweden is regarding the Go Biogas plant in Gothenburg. As you know, the plant is not in operation at the moment, it was in operation between 2013 and 2018. Now it's still mothballed and for sale. I received not very nice news last week that now the plant is in conservation state, but will most likely be dismantled. The aim of the facility was to produce SNG and biomethane, but unfortunately there were 2 phases planned, and it was only phase 1 built, and phase 2 was not even built. I think it's a pity. So it was a nice demonstration facility. It was demonstrated that the technology works well, but anyway, there were financial problems to keep the facility in operation because of imports of methane from Denmark. The next is LTU green fuel plant. Plant is as well in conservation state, and new regional funding is secured for 3 years to keep the plant from being dismantled. So let's see what happened. United Kingdom. So here I would like to say something about ATQ demonstration plant, which is near Birmingham. The aim is to gasify waste to produce syngas for power and heat applications, but also to produce biofuels like hydrogen. To status of November 2020, it was commissioning test on waste wood finished, and there were also other fuels, so RDF and other feedstock was tested. It is finished, and now the facility should be in operation. The second is Advanced Biofuel Solutions in Swindon site. It's a commercial demonstration plant for production of bio-SNG. I think now the construction is complete and cold commissioning is finished. So we will see if already hot commissioning was done. And waste processing is planned at the beginning of March. Project Bright is similar as Advanced Biofuel Solutions, but the scale is different. It's about 320 gigawatt-joule per year of bio-SNG plant, and it is located near center of HyNet project. So infrastructure should be available in 2025. In USA, I picked up 2 projects. One is Fulcrum Bioenergy, which is under construction. The aim is to produce Fischer-Tropsch liquids from municipal solid waste. So I think the municipal solid waste will be sorted and then gasified in indirectly heated fluidized bed steam reforming gasifier. The input should be 175 kilotons per year of sorted municipal waste. Startup should be with the beginning of 2021, so maybe in March. And the end product should be Fischer-Tropsch or Voxy, so fuel or Voxys. Fulcrum Bioenergy and Sierra Biofuels have now 12 new projects currently planned and underway. So please check the status report from USA to get the new information about that. The second is Red Rock Biofuels, Lakeview, Oregon. It's also under construction. It is also gasification for Fischer-Tropsch. Gasification technology should be TCG global steam reforming and Fischer-Tropsch by Velocis and emerging fuels technologies. Feedstock are forest residues, not waste. It should be produced cellulosic renewable jet fuel, diesel, and naphtha fuels. They have some offtakes with Southwest Airlines and FedEx Express. Construction should be completed this year, at the beginning of this year. Some words to France. Maybe you know already the biofuel project. The objective is to develop and demonstrate commercialization of full biomass to liquids chain. There were already several types of fuels tested here. And as you can see, it is also stepped project. At the beginning, it is sorted feedstock is prepared for gasification, and then the biofuels are produced. In November 2020, the commissioning and startup was completed. It was technology optimized and commercialization first contacts. So let's see what the next steps will be. There are also at the bottom the links to check the actual status of this project. The next is Gaia project for SNG production. Gaia is circulating fluidized bed as Repotec developed in Austria. The feedstock is woody biomass and no recyclable waste. Output should be biomethane 0.4 megawatt in demo plant. And now they are producing biomethane from sorted refuel fuel. And some news from Belgium. They have a no-tar reactor, no-tar, so it is a technology where the gas with high quality is produced. You can see the reactor on the right side. It is a tar-free char, and sorry, I forgot to tell you that the company producing no-tar reactor is a Kilowatt. Here you can see the biochar which they produce as a Syncraft. So here are the parameters of the char, and I would recommend you also to visit their website. They have a lot of interesting information there. And the next and the last country is Spain. In Spain, I have to say that the situation in Spain is not really optimal for gasification. Most of the main gasification projects which were implemented between 2000 and 2010 were based on small-scale gasification, small-scale to medium, using relatively clean biomass and agriculture residues. Unfortunately, the price of this feedstock was growing and the gasification was not really preferable. So many of research activities were stopped on the gasification, and at the moment there are just 2 institutes focusing on gasification, and there are only 3 producers of gasification plants. One of them is Ecutech. Ecutech has provided the gasification facility using the oleifomase waste, and it's in operation in Movialsa since 2011. The facility includes 4 gasification lines with installed capacity 6 megawatt and over 111,000 operating hours. They use Jenbacher engines for production of power. Besides the electricity, it produces also saturated steam and hot water. And the next is VT2 Energy. So as you can see here, there are 3 plants in operation in Spain. It's a bubbling fluidized technology, and as a feedstock, they use wood chips, meat and bones meal. So, and the last one is Neoelectra. You can see here the 2 facilities. Steam generation for industrial processes, and the second one is power generation through steam turbine with capacity of 8 megawatt electric. So I would like to say, if you didn't catch all the information during the presentation, please visit our website. Everything is in our status reports, which is published every 3 years. And in this year, it will be research activities in member countries published, as well as country report from Spain and country report from France at our website. And I would like to say also some information about the new project which will be published with the beginning of next month. So on Monday you can find it at our website. It is about emerging new technologies on gasification. It was written by Swedish member of the task, so I think there will be some interesting insight into future of the, maybe in the future of the gasification. And at the end, some conclusions. So in my opinion, thermal gasification makes sense because a variety of feedstock can be utilized, and in this way also waste can be disposed. There are already different gasification technologies available in commercial scale, and variety of possible products can be produced. So not only syngas for combined and heat production, but also biofuels, biochemicals, and we are not able to forget negative CO2 footprint of the technology because of carbon capture and storage, which will be through biochar maybe used in roads, in building materials, or for soil. And integration or combination of gasification with other technologies is possible. What is needed now, in my opinion, is necessary to recognize that gasification, which is based on biomass and waste gasification, can be a sustainable technology which saves our environment. And the combination of gasification with other technologies makes it much more attractive. So just use the gasification not only for combined heat and power production, but maybe include it into other technologies or produce furthermore also biofuels and biochemicals. And for this, I think it's necessary to have a clear and stable political frame which supports renewable energy and its products to encourage investors and implementation of the know-how which was won at research institutions. So, and that's it. I would like to thank you. I would like to thank also our members to their contributions to this presentation. And Thank you for listening, and I'm open for questions.
Thank you, Jitka, for this nice overview. There have been some questions, and I answered a few of them, but one that is still standing is, what is your opinion on the type of gasifiers used in Europe? It seems that it's more entrained flow than fluidized bed. What's your perspective on that?
In Europe, if we are talking about large-scale gasification, so I think it should be a half of entrained flow and half of fluidized bed gasification. But most of the gasifiers in Europe are in small scale. It's about 1,700 operational facilities. Most of the producers are stated in Germany as a Spanner or Burkhardt and so on. So they have a lot of operational facilities at the moment.
And another question that there seem to be a lot of questions popping in the chat now. What do you see as a future for plasma gasification?
Plasma gasification, in comparison with other gasifications, is not cheap, I would say. But it is open also for different difficult materials which can be handled in this way. Maybe just for this problematic feedstock, it's a good way, but the question is how much of this problematic feedstock is available in Europe or worldwide. So maybe it could be included into other technologies, but I think it's not really cheap technology.
Then there's one question from Sankar Bhattacharya. Difficult name for me, but if Patricia is still listening, maybe you can give an answer to that in the chat, because it's about a plant in the UK. I think I will ask all the speakers to look at the questions and give some further comments on that. I think what I learned today from the different presentations is that you see a little bit different developments in Europe, US, and India and China. But overall, I think the progress is going towards higher applications like biofuels and chemicals. I think we can learn a lot from there, from each other on this perspective. Also on the gas cleaning, because I think in Europe, for instance, the way we deal with tar in the gas and pollutants it's different than in India and China, I would say. And I think we could share a lot of experiences there. Another interesting thing that I noticed is that the biochar development is also in India and China. We're in Europe having several companies, and Jitka mentioned them, like Notar, Torgas, and Synkraft. They actually have a product now which is biochar, whereas many years ago it was considered a waste stream, but they upgraded the chars in such a way that you can utilize it as a soil enhancement or in different applications. So it's going from waste to product, and you see the same development in India and China. So also on this topic, I think we can learn a lot from each other. Having said that, I really enjoyed the different presentations, the different perspectives. I hope that the people listening in were also enjoying it. I think at some point we had 260 participants, so that's quite nice, coming from all over the world. And I think we will definitely organize a new one in the next triennium, or next year already perhaps, because it's such an interesting topic and there's so much development ongoing at the moment. Yeah, that's it for me now. I would again like to thank all the speakers and IEA Bioenergy for organizing this this webinar, and hope to see you in another session again. And if there's some last thoughts or comments from the speakers, then I think this is the moment.
So I was not able to go into the details in my presentation because of the time slot. So I'm sorry about that, but please, if you have any questions which will not be answered today, don't hesitate to contact me or Berend. So I think we will be able to answer everything. Thank you. And all these 3 presentations will be tomorrow online at our task website.
Also, if you are interested in my presentation, I would be happy to answer you by email, or maybe I can. Okay. Also, I will send the presentation to the IEA website. Right? You can go to more detail there.
Yes, please do so. Thank you.
Yeah, and from my side, I think it's important that this important topic, there's a cross-learning possible in this area, as you rightly mentioned. So maybe more such interactive session can be organized in coming months and time. So that will help in mainstreaming biomass gasifier as an important energy source globally.
Yes.
Otherwise, yeah. So that is what I hope that through this initiative one can achieve.
Okay, thank you.
Yes, thank you from ETA Florence Renewable Energies as well, and hope to see you again on our future IEA Bioenergy webinar.